Hello and welcome back to another Siemens S7-1200 and Factory I/O tutorial. It's still lockdown here in the UK. As you can tell, I haven't had my haircut now for weeks on end, but hopefully I've got something interesting for you. We have an Arduino which communicates with the PLC using the Modbus TCP IP protocol. And if I rotate this potentiometer, the water tank starts to fill. Why? Well, the potentiometer's rotational position is read by the Arduino's analog input and stored as a numerical value internally in the Arduino's memory. Then the PLC, being on the same local area network, is able to read the values stored in the Arduino and use it as a set point to control the water level in the tank. So how is this done? Well, stay tuned to find out. Okay, welcome back. So some of you may have realized a slight change in agenda from what was mentioned at the end of the previous water tank video in part 2. Well, just to say, I will still be implementing PID control after these next few videos on Modbus. And if you haven't already seen the previous 2 water tank videos, the links for these are in the description below. Now, before we start, let's take a closer look at the Arduino setup. Firstly, we have an Arduino Uno AT-Mega328 compatible board at the bottom. And sitting right on top of the Arduino, we have an Ethernet shield, LAN W5100. So I'll just take them apart so you can see them. So that's the Arduino and that's the shield. Then we have a 10 kilo ohm potentiometer with 3 pins connected via these wires to the Arduino shield, which is linked using the same pins directly to the Arduino. The wiper pin on the potentiometer goes to A0, one of the analog inputs on the Arduino, and ground and 5 volts go to their respective inputs. Now I'll just put this back together and then we'll make a start. As you can see, it's sometimes difficult to get these pins lined up. And you have to be careful, otherwise you'll bend the pins. There we have it. Okay, we are ready to have a look at programming the Arduino. We will be setting up the Arduino as a server, sometimes referred to as the slave, and the Siemens PLC will be the client, sometimes referred to as the master. Right, now the Arduino code is quite short, so I'll try to explain it step by step, and hopefully it will make sense. I have to point out that I'm not an expert in the Modbus field, and all I've done here is read up as much as I could about it, watched some videos, and being a systems engineer, I made some modifications to suit what I was trying to achieve and managed to get it working. Okay, let's open up the Arduino IDE. I'll make a bit of space at the top. The first thing we will need to do is include 4 libraries, 2 of which are already installed when the Arduino IDE software was installed. The remaining 2 libraries are third-party libraries, which came from this website. And if you scroll down to the section on Modbus IP, it mentions which libraries are required. So the first 2 libraries, SPI.h and Ethernet.h, are the libraries installed automatically when the Arduino IDE is installed. So let's include them in the code or sketch, however you would like to refer to the program. I'll just put the cursor there on line 2, and from the menu select Sketch, then include library, followed by SPI. Let's do the same again, but this time select Ethernet. OK, the next two libraries required, Modbus IP.h and Modbus.h, are the third-party libraries, which we will need to download and install. So let's save what we've done so far and then close the Arduino IDE so that we can install new libraries. Then from the website, at the top of the page, click the green button, Code, then Download Zip. We can then go to the download folder where it should say Modbus Arduino Master, which really is server or slave. Then we can right-click on the folder to extract all, but first I will move it to the folder I created on the desktop for downloads. I'll then open the folder and extract all from there and accept the destination by selecting Extract. We can now see the extracted directory Modbus Arduino Master. If we have a look in the folder, we see a list of the files as outlined on the website, including the libraries folder. So let's go into the libraries folder, where we can see 5 different Modbus libraries. Now, as we are using the LAN W5100 Ethernet shield, we need to copy the two libraries Modbus IP.h and Modbus.h and place them in Arduino/libraries. So let's do that. OK, now let's include these two libraries in the code. So go to Sketch, Include Library, and this time you will see contributed libraries with the other two entries we require. So let's include them one by one. OK, that's done. I'm just going to save what we've done so far and call it Modbus Arduino 2, then save. Now I'll just tidy the code up, getting rid of unnecessary spaces so that all the code we write here will fit on the screen. OK, let's go back to the website for a moment, and I'm under Notes. Apart from saying Modbus IP uses port 502, which we will also set up in the Siemens PLC, the first paragraph says we need to uncomment the following, which is the define TCP keep alive line. So let's do that. Let's edit the Modbus IP.h file. I'm using Notepad and remove the 2 forward slashes and then save. OK, going back to the notes in paragraph 2, it talks about an offset, which we will come to shortly. Now, if we scroll back down to the section Modbus IP, this is the section that applies closely to what we are doing, and therefore I will be referring to this section when coding. Right, so we've included the libraries the program needs to use, so now we can declare some of the variables. So first we'll declare setpoint as an integer, which is 2 bytes, 16 bits, which are values between minus 32,768 to 32,767. Then on the next line, we'll declare the Arduino register memory address setpoint _IR and make it equal to 100. This is done by declaring const integer and the variable setpoint _IR, which is the name of my choosing, and making it equal to a register address. When we get to the Siemens PLC, we will make use of this register's content for the water tank level set point. Now the register is address 100, which equates to 30,101. Now that may sound a bit strange if you haven't dealt with Modbus before, but I'll try to give an initial explanation. It's 30,000 because the address of Modbus input registers start from base 30,000. Then because we have defined 100 as the address, we need to add 100 to the 30,000, and then an additional 1 for the Modbus offset. Therefore, we end up with 30,101. Now, this may become a little bit clearer when we start configuring the PLC. However, if you have a look at the S7-1200 Programmable Controller System Manual in section 13.5, Modbus Communication, and scroll down to page 1097, it shows the Modbus data address. Interestingly, it refers to this register as a word. I've put the system manual version and date in the description below. Okay. Next, set the Modbus IP object or instance, as it is sometimes called, by declaring Modbus IP MB. We can see an explanation for these last two declarations on this web page again. Okay, now we move to the setup section of the sketch. I'll first delete the comment, and we'll enter the speed for the serial communication, which is a baud rate of 9600. Now I need to enter the MAC address and IP address for the Arduino. So if we look at the notes again, we'll just copy this part into our code and configure the instance by using mb.config. Now I have a feeling this should be byte before MAC and also IP, but I'll leave it for now and check it when we try to compile the code. Okay, we can now carry on by defining the register type. So let's go to the Modbus IP section again, and it shows mb.add ISTS. But we need something slightly different. I'll put this in the code for now and then edit it. What we need is mb.add IReg. This is shown under Modbus jargon on the bottom line of the table here. mb.add ISTS is for digital inputs, and we need an analog input to input register. So let's go back to the code and give the input register the address setpoint _IR, which is 30,101. The last thing we do to complete the Modbus IP server is add in a task statement early in the loop section. I'll just get rid of the comment and tidy things up a little again first. Then if we go back to the Modbus IP section in the notes, we can see how this is done. I'll just copy and paste this as it is. Okay, now we can start reading in the value of the potentiometer and placing it into the input register so the PLC can read it and act on it by opening up the fill valve. First we'll read in the analog input a 0, which is written into the variable setpoint. On the next line, we take the value in the setpoint variable, which is between 0 and 1023, which represents 0 to 5 volts, and we'll place it in the input register, which is addressed by setpoint IR, by using mb.ireg, which is the other library method listed under Modbus jargon. Copy it and paste it in the sketch. So now add MB in front, and referring to the info under Modbus IP again, I'll copy and paste again and make some modifications. I'll paste it over what we've already done. So ISTS should be IREG, then switch ISTS should be setpoint underscore IR, and the last bit should be setpoint, meaning the analog value from 0 to 1023 will be written into the input register addressed by setpoint IR, which is 30,101. Okay, now I'd like to print the value of the setpoint to the screen by using the serial monitor. So I'm going to create a function and call it display setpoint values. And before I print the values, I would like to see the message saying setpoint value equals followed by the actual setpoint value. So to do that, we'll use a string. So first I'll define the string as print str, then make it equal to setpoint value equals plus, and add the value to it. Next, I'll print it to the screen using the serial println command. I'll then go back to the loop function and call display setpoint values, followed by a short delay of 200 milliseconds before going through the loop again. Okay, let's save the sketch and compile to see if there are any errors in the code. There seems to be an error with the MAC address as suspected. So I'll edit it and put byte first. I'll do it to the IP address line too. Let's compile again. Okay, that has solved that one, but there seems to be a missing semicolon on line 18. So I'll add that in. Then compile one more time. Oops. Yes, I've written analog incorrectly, so I'll get rid of the UE at the end. And this time, we have compiled without any errors. Great. Now, before I upload the code to the Arduino, I'm going to check that we are on the right COM port and we have Arduino Uno selected. So upload, and all is okay. I'm just going to bring up a command prompt in Windows and I'll type ipconfig and no, that's not what I wanted to do. What I wanted to do was ping the IP address 192.168.1.120 and see if the Arduino is indeed contactable via the network. And yes, it is. Great stuff. I'll do it one more time. Use the up arrow and enter. It seems fine. I'll save the sketch Oh, I just forgot to view the serial monitor. So tools, then serial monitor. And although we're getting the right information, I wanted the results of every scan to be on a separate line. So let's see what's happening there. Serial print, it should be serial print ln. So I'll make that change, save the code and test again. I forgot to upload the sketch, so let's do that and then clear the output. And that seems okay. The potentiometer seems to be on 0, so let's rotate it clockwise. Let's rotate it back to 0. Great, that seems to be working okay. Back up, then down. Great stuff. So that now all seems to be working as expected. So in the next video, we'll configure the PLC to read the input register so that the value can be used to open the fill valve to let water into the tank. Again, thanks for watching. If you've enjoyed the video and would like to learn more, then please click the subscribe button and the bell so you'll be informed as soon as a new video is uploaded. And also please see the links in the description should you wish to get a free 30-day license of Factory I/O, and also check out my Patreon account. And I'll see you in the next video. So thanks for watching again, and bye for now.